So yeah. So first of all, I'll go over general AMC8 strategy. So first of all, clearly the rules. So the rules are just they're 40 minutes. So first of all, the rule 40 minutes, and you get 25 questions, and so that's the basic rules of what the test is like. And so as for scoring, you get 1 point per correct answer, and 0 points if your answer is wrong or blank. And so some general strategies. So first of all, skip the questions you cannot solve and move on to the next question, because it's possible that it's just that one problem you're currently unable to solve that you cannot do. And the next couple could just work. And of course, if you have time, and if you finish or you can't do, or you're unable to solve any of the rest of the problems, then you can just go back. And so in general, you should probably take some time to check your answers, just because it would be best for you to check your answers and make sure you haven't accidentally messed up somewhere obvious but you didn't notice yet. And so if you run out of time at the end, then you should just guess on everything that's blank. And it should be pretty obvious from the fact that a wrong answer and a blank answer both give you 0 points. So obviously you should just try to guess and see if you can actually get a correct answer. Because otherwise, one is a guaranteed 0 and the other is 0 with the probability of becoming 1. And so yeah, these are just some general rules. Yeah. And so now, as for the mock AMC tiebreakers, so those tiebreakers, if you do not know, were about mid-level AMC8 or so. Maybe some are early to mid and some are mid to late. And so yeah. So now I'll start going over the question for the tiebreakers. And so before I go over each problem, I will first give you 1 or 2 minutes probably to try and solve it on your own before I go over it. All right, so I guess that's enough time. Oh, right. And by the way, if any of you ever get an answer, feel free to just privately send it to me. Anyway, so on number 1. So I have an infinite amount of 4 desserts: cake, cookies, ice cream, and chocolate. And so every day I eat one, and I never eat the same dessert 2 days in a row. So if I choose to eat cake on Monday and on Sunday, then how many ways can I choose the desserts for Tuesday through Saturday of that week? So, so I'll first write out the week. So 1, 2, 3, 4. Actually, I'll add wait 1, 2, 3, 4, 5, 6, 7. So this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And so you can obviously see that this is just exactly 1 week long. So I'll just represent cake with an A, cookies with an O, ice cream with an I, and chocolate with a C. So on Monday and on Sunday, I know that, or given that I ate cake. So yeah, obviously, so what would go on to the places for Sunday and Monday is just going to be, okay. 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 Here we go. And so yeah, and so what we're choosing are the desserts for these couple. So first of all, you can see that Saturday basically cannot be cake. So first of all, so what we can do here is we can actually just consider this. 1, 2, 3, 4, 5, 6, 7. So we can first consider just the fact that I ate cake on Monday and ignore the fact that Sunday was cake. And so I'll just count the number of, I'll just count the number here where there are 0 restrictions on what to eat on any of these days, except for, sorry, so where there's 0 restrictions on because of what I ate on Sunday. And next, I know that Saturday cannot be cake, so all I can do is subtract out the cases where I ate cake on Monday and Sunday. Saturday. And so in order to find the one where I ate cake on Saturday, if we can just see that to find it, we just need to find the number. So it would be the number of things that satisfy this minus the number that satisfy this. And this, on the other hand, we can repeat the exact same process for what we used just now on Sunday. And so this would turn into, so the total number from Monday through Friday, and plus, because it's really minus negative of this, or minus this, I minus the number of ways I can eat cake on Monday, and then also eat cake on Friday. And so this just repeats onward, so on. And so eventually we can just see that So Wednesday is not cake. Sorry, Wednesday is cake. So if Wednesday is cake, then the number of the form. So if I eat like this, so if we remember, there are a total of 4 different kinds of desserts, and only one of them is cake. So there are 3 ways to choose this dessert in the middle. And the reason we won't continue onward from here is just because if we continue onward, we'll use the number such that I ate cake on Monday and Tuesday. But if we remember, I already ate. We have the restriction that we can't eat 2 of the same desserts. So this is just 0. And that's why this is 3, not 4. And so the probability that Wednesday isn't cake, the number of ways that Wednesday is cake is this. So Wednesday, okay. So the number of ways such that Wednesday not cake is simply just the number of ways I can choose these total. The total ways to eat desserts for Tuesday and Wednesday, which will be 3 times 3, and minus 3, which is this number, which is the number of ways I ate cake on Wednesday. So 3 squared minus 3, which is 6. And so that means that the number of cases where Thursday is cake is 6. And so that means that the number of ways where Thursday is not cake is 3 cubed, because it's 3, 3, 3. And minus 6 is 21. And so the number of ways where Friday is cake is 21. And so the number of ways where Friday is not cake is 3 to the 4th minus 21, which is 60. And 3 to the 4th is just because that's this one here. And finally, the Saturday is cake is just 60. And I'll just draw arrows between the numbers that are equivalent, which are these. And yeah, this process just continues onward. And so Saturday is not cake, is 3 to the 5th minus 60, which is 183, which is 183. And so the number of ways where Sunday is cake is 183. And so the final answer is just 183. And that coincides with the choice B. And so that's this first question. So are there any questions regarding this problem? Okay, well, if not, then I'll just once again give you a couple minutes to solve tiebreaker question number 2. And in the meantime, if you have any questions or manage to solve it, please just private message me. Or you can public message, but not public message me questions, but definitely never public and message me an answer. Okay, well, now start going over this problem. So number 2. We have let's go 6 books, 1 history, 2 different math books, and 3 different English books. And so I want to order them such that there are no books of other subjects between any 2 books of the same subject. So the history book we can just represent as an H, the math books M1, M2, and the English books as E1, E2, and E3. So now we can imagine this as H as a group of H, this as a group of M's, and this as a group of E's. So if there are no books of any subjects between any 2 books of the same subjects, then that means that, then that just means that none of them, that all of the books are in the same group. So what I mean is like this E1, E2, E3 must always be in some permutation of itself. And there are no other words between it. Or books, sorry, not words. So yeah, and so that means that the first thing we can do is find the order in which we're arranging history, math, and English. And so the number of ways is 3 factorial, which is equal to 6 for this one. For the number of ways to rearrange H, M, and E. And so clearly wherever H is, there's just 1 history book. So it just gets put there. And now for the math books, there are 2 ways we can arrange them in group M. So either it's M1, M2, or M2, M1. And that's because it's 2 factorial. And as for E, there are 6 ways. And they're E1, E2. I'll just write 1, 2, and 3 to represent E1, E2, and E3. So 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. And well, you can imagine E being there. But yeah, those are the subscripts. And so this is just 6. And it's also through factorial. And that's just because this is almost a basic definition of how the factorial is used. Sorry, basic application of the factorial. And so that means that the number of ways is just 6 times 2 times 6, which is 72. D. And so that's this question. So does anyone have any questions about it? And if not, in the meantime, I'll move on to 3. And once again, as I said, if you have any questions, please ask me and I can answer. And otherwise, if you have any answers, also just send them to me. And just by the way, it would be more preferred if you could send me letters, the letter choice, not just the number itself. Because you should probably get slightly more used to that, the fact that you will need letter choices. Okay, well, I guess that's about time. So I'll start going over this problem now. So number 3, it's Christmas Eve, and Santa is dropping presents in the streets. So there are 10 houses, and so he's forgotten who's supposed to receive presents and who's supposed to receive coal. So if you if you don't remember, so if Santa splits kids into either naughty or nice, and nice kids will receive a gift or presents, same thing, and naughty kids will receive coal. And so Santa delivers presents or coal in such a way that as many naughty kids receive coal as possible. So if each child has an equal chance of being naughty or nice, what's the chance that Santa's strategy will make sure all naughty kids will receive coal? So this problem is a bit tricky, and the moment you realize what it's talking about, what it really means, then you can just immediately get the answer. And it's because if Santa makes sure that as many naughty kids receive coal as possible, for all he knows, it's possible that everyone, that for example, that everyone is naughty and no one is nice. So I'll just write a naughty with an X and a nice with a check. So for example, 7, 8, 9, 10. So if the street as in terms of naughty and nice looks like this, well then Santa would have to drop coal in every house. And at the same time, all that Santa really cares about is that as many naughty kids receive coal as possible. So in reality, because this is an actual possibility, to make sure as many naughty kids receive coal as possible, all that Santa will do, and all that Santa is able to do really, is give every kid in the house coal. Every house's kids coal. So the probability that all naughty kids will receive coal is just 1. And that's because it's literally impossible for any kid to not receive coal. So all kids will definitely receive coal, and so that means that definitely all the naughty will receive coal. So that's this question. And if you have any questions, just speak up or tell me through any chat version of the chat. And otherwise, if not, then if you don't have a question, then I'll move on to problem 4 on the screen, and once again give you a while to try to solve the problem on your own. Okay, well, this time no one got it right, but still, this time I'll start going on. So on Halloween, Alex got a total of 4 bags of candy from his classmates. So the least number of candies in any bag was 5, and the most was 9. So Alex got a total of 25 candies. We have 5 and 9. So this is the least, and this is the max. So if Alex received a total of 25, so that means that, well, we already know that, oh, anyways. So we know for sure that Alex got a bag of 5 and a bag of 9, and that's because it's literally given. And so this sums up to 14. And so that means that if Alex received a total of 25, what that means is the number of combinations, sorry, the total number of sum of the other 2 bags, because we know he got a total of 4, is simply just 25 minus 14, or 11. And now, so the least number is 5. So both bags have at least 5, and obviously it's possible for the bags to have 5 themselves, because all it says is the least number of candies. It doesn't mean it has to be, there's only one bag with 5. So 5 plus and 5 plus. So yeah. And so this already sums up to 10. And we can see that the sum of these 2 bags must be 11. And now there's only one there's only one more candy, really. This means that there's only one more candy that can go into either this bag or this bag. Either way, it tells us these 2 bags have 5 and 6 candies in some order. And there are no other possibilities, because this is the only way to split up that plus 1. And in addition, this problem says without regard to order, so 5 and 6. So we just know that it's 5, 5, 6, 9 in some order. Yes. And so the problem answer is thus just 1. And yeah, it's just the one only possible answer here is 5, 5, 6, 9. And the reason we're not dealing with any fraction of decimals is just because it's impossible to have a fraction of a candy in the first place. Or at least, I don't think you will ever receive a fraction of a candy from anyone. Anyway, so yeah, I'll just move on to the next question and give all of you a minute or so to solve it on your own. And once again, if you have any questions for anything done before or of the kind, then just private message me or message me in any way. Okay. Well, okay. So I'm just going to start now. So problem number 5. Brian walks home to school and back again every day. So home, school. Okay. So along the way to school, he passes by the library, and on his way home, he passes by the store. So Brian's home is 5 blocks west and 2 blocks north of the library. So that would look something like this. 2 blocks and 5 blocks. And the library is 3 blocks west and 1 block south of the school. Oh, right, store and school have the same initial letter. So one is SC and the other is ST. So, yeah. So now school goes somewhere about here. And the distance here is 1. And this distance is 3. And that's just read off of here. And so the store is 2 blocks south of the school. So it would be here. And so given that Brian takes the shortest possible paths, in how many ways can Brian walk home from school? So it says walk home from school. So we can see that if he's walking home from school, he passes by the store. And he does not pass by the library at all. So the fact that he passes by the library is irrelevant. So that means that we can effectively ignore this. So this is just 8. And this distance is 2 minus 1, which is just 2. So, here, yeah. So Brian's path home from school simply just he first walks from school to the store, which is 2 blocks south. And so obviously the fastest way to do this will just be to directly walk the 2 blocks south. And there's only one way to do this because he's just going in one direction the whole time. And so now he goes from the store to his house. And when he does this, he moves 8 blocks west and 3 blocks north. And so the number of ways to arrange this is basically the number of ways to write 8 W's, and 3 north. So yeah. So there's is just so there are a total of 11 letters here. So 11 factorial, which is the number of ways to arrange 11 distinct letters. Then we divide by 8 factorial, which is the number of ways to rearrange the W's because we are actually unable to. And then as for the number of ends, for the ends we do something similar. It's just through factorial. So all in all, the number of ways for Brian to walk home from school is 11 factorial divided by 8 factorial times 3 factorial. And so this is 11 times 10 times 9 over 6. And this is just 15. Because 90 divided by 6 is 15. So this is 11 times 15, which is 165. So the answer is B. And so that's it for this question. And so now I'll move on to the next question. And so if you have any questions regarding anything that I went over before, please just send me a private message or something similar, and I will try my best to answer. And also I will give you a short while to try to solve this problem on your own. Okay, so I think enough time has passed, so I'll start going over this problem. Um, okay, I think I'll have to restart here. Okay. I'll just share quickly. So yeah, here we go. That's better. So number 6. Robert is handed 10 slips of paper that contain numbers from 1 through 5. So he flips them over and sees that none of the slips have even numbers, and the number of slips that have a prime number is 1/4 of the number of slips that have a non-prime number. So the probability that when Robert randomly chooses one slip, the number is 1. So we know that none of the slips have even numbers, and they all have numbers from 1 through 5. So that means the slips all have a number from 1, 3, and 5. So we can let A be the number of slips with 1, and B be the number of slips with 3 or 5. Okay. And so, yeah. So that means that the fact that the number of slips that has a prime number, and which is 3 or 5, because 1 is not prime, and it's the only one, in fact, of 1 through 5. So this is non-primes, and these are the primes. And so the fact that the number of slips that have a prime is 1/4 of the number of slips that have a non-prime can just be translated into B equals 1/4 A. So yeah. And also we have that A plus B is equal to 10. And so we can just solve in any manner that we want. And what we get is that AB is equal to 8, 2. And so we can just see that the chance of randomly choosing a slip or 4/5 D. And so that's this question. And so, yeah. And so now, if you have any questions, just once again, notify me in some manner. And if not, then you can just try to solve number 7 on your own. And I'll give 1 or 2 minutes. Okay. Yeah, so I'll just start going over number 7. So a triangle and a rectangle have equal areas, and all sides are of integer length. So given that the triangle is a right triangle, so we want to find the ratio of the perimeter of the triangle to the perimeter of the rectangle. So yeah, that's this question. So for this one, honestly, the best way to do it is just the fastest way really is just to do it by experimentation. And so we'll just use a 3, 4, 5 right triangle. And so the perimeter is 12. And so, however, oh yes, and also the area is 6. So for a rectangle with the same area as a triangle, it could be something like 1, 6, 1, 6, or it could be 2, 3, 2, 3. This has perimeter 14, and this has perimeter 10. But at the same time, the perimeter of the triangle is fixed, and the perimeter of the rectangles is not. So the ratio of the perimeter is not a set value. So it cannot be determined, E. And so that's this question. And so if you have any questions about anything about the previous, or have any requests for me to do, then just tell me and I'll answer. And otherwise, if not, let's do this question. Okay, so I'll start going over this question. So number 8. The hypotenuse of a rectangle is 15, and it's a hypotenuse and it's right. And the area is 45. So we want to find the perimeter. Okay. So if we let the legs of the triangle be A and B, and also this is right, this is a rectangle. So by the Pythagorean theorem, the hypotenuse is just a squared plus b squared and the square root of that. And so this tells us that a squared plus b squared is equal to 15 squared, or 225. At the same time, the area is of the form AB over 2, and is 45, so AB itself is 90. So to find the perimeter of the right triangle, we can see that A plus B, which is basically the perimeter minus the hypotenuse, because all we'll do is add the hypotenuse back in later. So the sum of the lengths of the legs is just A plus B, which is A squared, the square root of 2AB plus A squared plus B squared. And that's just because this is A plus B squared expanded out. And so the A squared plus B squared is 225, whereas this is 2AB, or 180. So this is equal to the square root of 405, and this is the square root of 81 times the square root of 5, or 9 root 5. And so the answer is 15 plus this, which tells us that the answer is E. So that's the answer. And so if you have any questions to ask, please just tell me. And if not, then we can move on to number 9. Okay. So I guess I'll start going over problem number 9 now. So I have a rectangle with the length being twice as long as the width. And so if the area is 90, okay, oops. So the tab itself has closed for no apparent reason. So here, okay. So rectangle with the length twice as long as the width. So if the area is 98, find the perimeter. So, okay. So the length, which we will denote as L, is twice as long as the width, which we will symbolize with W. And so if the area of the triangle is 98, I mean rectangle, sorry. So the area of a rectangle is the length times the width. So this means that 2W times W is 98. And because the area is 98, so W squared is 49, or W is 7. In reality, W can be positive or negative 7, but the width of a rectangle is always going to be positive. So W is equals to 7, and so length will be twice that, which is 14. And so the perimeter is 2 times length times plus width, which is 2 times 7 plus 14, or 42, which is C. And so if you have any questions, once again, if you have any questions, please just let me know and message me somehow. And otherwise, you can try problem 10 for a while. Okay. Well, then I'll just go over number 10 now. So what's the greatest possible integer that can divide both 5,353 and 3,710? So yeah. So the greatest possible integer. So first of all, this first number is 5,353, which is just 53 times 100 plus 1. Or 53 times 100 plus 53 times 1. And just, you can use the distributive property. So it's 53 times 101. And this other one is 3,710 is 10 times 371, which is 10 times 7 times 52. And to find the fact that 731 is equal to 7 times 53, you will just have to manually check the primes. And so this is just 2 times 5 times 7 times 52. And so both 53 divide these two numbers, and since 101, 2, 5, and 7 are all primes, that means that the answer is just 53, which is C. So is there anyone that has any questions regarding problems on this test? Okay, well then, I guess if not, well then, thank you for coming. And so, yeah, have a great rest of your day, and thank you, and bye. And have a nice weekend. Have a nice long weekend. Thank you.